If x is a discrete random variable with probability mass function f of x, we can determine the median by finding the middle value if the experiment is repeated a large number of times. This is generally hard to do, but calculus is easier. And that means if x is a continuous random variable with PDF f of x, the median is the value that satisfies the probability that x is less than the median is 0.5, and so we can find the median by solving the integral equation. Let x be exponential with a mean of 20. Let's find the median. The exponential distribution described will have PDF. Since our random value has probability 0 for anything less than 0, our interval of integration will actually be from 0 up to the median. And so we have, solving this equation gives us and so x is about 13.86. Or perhaps we have the median, so let's say we know that losses due to pterodactyl attack are exponentially distributed with a median of 200. Let's find the mean loss. So we can use the CDF of the exponential distribution. And note, in this case, we don't actually know the parameter, but we do know the median. Remember, the CDF gives us the probability that we're less than or equal to the argument, and so our median satisfies that probability is 0.5. And that gives us our equation. And since we actually know the median, we can substitute that value in and get an equation where lambda is the only unknown. Solving our equation gives us and remember, for the exponential distribution with parameter lambda, the mean is the reciprocal of lambda, and so the mean value is a common situation in the real is for the payoff to be limited by a cutoff. For example, expenses may have a maximum reimbursement. So suppose conference expenses in thousands of dollars are modeled using some function. However, reimbursement is limited to $200. Find the median. So remember, success in life is a matter of habits. In this case, note that we're given a PDF, but there's an unknown constant in this PDF. And since we don't know the value of this unknown constant, we should try to determine it. Now, since our probabilities are non-zero only in the interval between 0 and 1, we know that the integral over this interval must give us 1. And so we solve, and we find the value of c. Now, the median expenses will satisfy the equation. And remember, paper is cheap. We've already computed this integral. We just didn't know the value of c at the time, so we can shortcut some of those steps, and we can solve our equation to get and so that means our median expenses is $129. Now, at this point, remember, concrete doesn't hurt. If we imagine 1,000 conference expenses and put them in order, it might look something like this. We have 500 expenses that are up to the median, 129, and then 500 more expenses that are more than the median. But remember, there's a cap on the reimbursement. So the reimbursements would look something like this, where anything that's under $200 would be reimbursed in full, but everything that's over would only be reimbursed for $200. And so the median reimbursement is still between the 500th and 501st values, so it's still 129. Now, a useful strategy when learning something, ask a different question. Let's change the question a little bit and make our maximum reimbursement, how about $100? So again, our expenses might look like this, but since the maximum reimbursement is $100, then anything less than $100 would be reimbursed at the full rate, but anything more than $100 would be reimbursed just $100 worth. And now our median occurs between these two values, and so the median reimbursement is only going to be $100.